Myself, Srinivasan, faculty in the Department of Mechanical Engineering at Sri Shima College of Engineering. In the previous lecture, we discussed about the single layer perceptron. Today, we are going to look at some numerical problem on single layer perceptron and multi-layer perceptron. So, as we discussed in the single layer perceptron, that single layer perceptron can handle only linearly separable data. And if you look at a numerical problem on single layer perceptron, so we have if you look at the graphical representation, we can use this linear boundary to separate two classes. Okay, so one is star, another one is circle with red one. Okay, so if you look at if you use the logic gate, that is OR gate here, then the input is x1, x2, and 0, 0, and 0, 1, 1, 0, 1, 1. So either or another should be 1, and then if that is the case, that the output is going to be 1, 1 only. 1, 1, 1. Okay. So the corresponding weight we have fixed is 0.1 and 0.1 and 0.3, and that is the initial one, and learning rate is going to be 0.2, and the threshold value is 0.5. Okay. So error can be calculated based on target and computed, and here we use perceptron learning rule, okay, to update the weights. Okay, so that you can look at our previous lecture on single layer perceptron. There we discuss a lot about single layer perceptron. Okay, so the epoch 1, and already we fixed 0.1, and for the case of W11, and another case is 0.2, and W1 is 0.1, and W21 is basically 0.3. Okay, so this is our initial input 0, 0, 0, 0, 0, 1, 0.01 and 0.3, and we have, when we computed all these things, that we got there is no error in it, and we updated weights are going to be, that change in weight is going to be 0, 0. Okay, so when we computed for the case of 0 and 1, and we got the similar weight, I mean we have the similar weight, and the change in weight is going to be in the case of del W21, and this 0.2. Okay, so this 0.2 has to be updated. Basically, the updated weight is basically and the old weight plus and the change in weight. Okay, so what is happening, that there is a shift from 0.3 to here 0.3, 0.32, and 0.5. Okay, so if you update all these things, the error if you look at in the epoch 1, and still we have error in the case of 0 and 1 and 1, 0, that is 1, 1, that is not matching with the target one. So we have to go for the next epoch. So when we go for the next epoch, similarly the way we do, then finally we get error in the case of 1, 0. So when you go for further epoch, and you will not see any error, and that whatever the weight updated is going to be the final one. Okay, so what we have applied that single layer perceptron for the logic gate, that is OR, so you can easily separate the classes using the linear boundary. In case of XOR problem, if you look at either one of should be 1, that is 1. If all the two values are x1, x2 are 0, and x1, x1 are 1, it is going to be 0. So we can't use a linear boundary. So then we have to use the two decision boundaries to separate the classes. Okay, so that's why I can say single layer perceptron cannot solve XOR problem. So far we discussed about single layer perceptron, and in single layer perceptron we don't have any hidden layer, and we have only output layer where we get summation and activation both will happen. In case of multi-layer perceptron, we will have one hidden layer, okay, and one output layer will be there. Okay, so in both hidden layer and output layer we sum, and summation and activation both will happen. Okay, so this is the second one. If you look at third diagram, if you look at the other diagram, that you could be able to see how mathematically it is summed up and it is getting activated. Here we can use either one of the nonlinear activation function here. Okay, so the difference between single layer and multi-layer is in multi-layer perceptron we use the hidden layer. Because of that, we can able to classify the linear and non-linear data both. Okay, so that's why it can be used for both the classification and regression problem. So how the multilayer perceptron is able to classify the nonlinear data? Okay, as long as you have a this is our x1 x2 are going to be input layer, and these are going to be a hidden layer. This is going to be output layer. Okay, so when that the first neuron in the hidden layer will give you the one linear boundary, so that is going to be this one. Okay, the second one is going to be this one. So based on that, we can able to classify the nonlinear data. So what is nonlinear data here? The triangle with the red mark is going to be a triangle with the red mark is one class, and the circle with the yellow is another class. Okay, so we can use this linear boundary, and we can able to classify the nonlinear data. Okay. So this is a numerical example for the case of multilayer perceptron, and we have input layer x1, x2, and bias is going to be 0.5. The input is b1 is going to be 1 here, and x1 is 1, and x2 is 2, and all will get summed over here, and we apply the activation function over here. And similarly, we can do for the next neuron in the hidden layer. So when you do all summation and activation, this is the value we got. And in the case of first neuron in the hidden layer is 0.57, and the case of second neuron in the hidden layer is 0.88. Okay, when we apply this weights, and finally we end up with final output is going to be 0.5. Okay, so this is a way we have to do numerical problem for the case of multilayer perceptron. Okay, so in both hidden layer and output layer, we use sum and activation function over there. So what is the difference between the shallow neural network and deep neural network? Deep neural network, basically, if you have 2 or more hidden layers in the neural network, that we can say the deep neural network. And shallow neural network is, as long as you have only one layer of hidden layer, then we can call it as shallow neural network. So as long as you keep on increasing the hidden layer, and what will happen is that the complexity will increase. Okay, which is going to be more useful for nonlinear problems. Okay, so the computation cost is also, as long as you increase the deep neural, whenever you use the deep neural network, the computational cost is going to be very high. Okay, and since we use a nonlinear activation function, and obviously we may expect some vanishing and exploding gradient issues. Okay, so as a result, where we can use a shallow and deep neural network. Okay, in shallow neural network, basically used for some linear regression and simple binary classification and all. As long as you go for image recognition and speech recognitions and NLP based work, and we can go for the deep neural network. And in terms of architecture, I mean in terms of the working principle, and shallow neural network uses feature extractor, and whereas deep neural network uses feature extraction and classification, same within the same architecture. Okay, so that is the way it works.